Assalamu alaikum. I hope you guys are doing great, and a very warm welcome from my side to the new session of Quantitative Analysis for Management 2. So before starting the lecture, I would like to discuss the course outlines. We will cover the test of hypothesis for one sample and two sample in chapter 10 and 11. Then we will see how to analyze the variance in chapter 12. Chapter 13 and chapter 14 is all about the correlation regression and their estimation by using statistical formula. Then chapter 17 and chapter 18 is about the non-parametric testing. So this is the brief preview of your course outline. I will also share the detailed one with the CR. So let's start with the statistics. Statistics is basically subdivided into two categories. The first one is descriptive statistics and then inferential statistics. Descriptive statistics is all about summarizing, organizing, and presenting the data into a more informative way. However, inferential statistic is driving the conclusion from that particular data. So it means inferential statistics is based on the descriptive statistics. So it's good to understand the descriptive first and then move towards the inferential. So I hope you guys are familiar with the concepts we have studied in previous semester. And if you do not have a clear understanding, then you can ask anytime. Otherwise, please give a brief review to the chapter 8 and chapter 9 particularly, because the foundation of inferential statistics was taught from there. And a very important theorem I would like to discuss here, which is central limit theorem. In central limit theorem, we assume that if population is following a normal distribution, then sample from that particular population will also follow the normal distribution. On the other hand, if population does not follow the normal distribution, then we will increase the sample size and it will gradually reach towards the normal distribution. So this is the definition, or you can say an explanation for the central limit theorem, which is a foundation for inferential statistics. So let's start with the chapter 10 from the book which I have recommended to you guys in previous semester. So let's see what are the goals we are going to achieve in this chapter. So we will start from the definition of hypothesis and hypothesis testing. Then we will describe the 5 steps of hypothesis test procedure. And then we will see what is the difference between one-tailed and two-tailed test of hypothesis, or you can say the directional and non-directional hypothesis. Then we will conduct the test of hypothesis about a population mean and for population proportion as well. Then we will find out what are the type 1 and type 2 errors, and we will compute the probability of type 2 error. What is hypothesis testing? Hypothesis testing is a procedure based on sample evidence and probability theory. So we need to have a sample to calculating for certain estimates and probability theory. So we will see the chance of occurrence of an event used to determine whether the hypothesis is reasonable. So these two things will help us to determine the hypothesis statement is a reasonable statement or an unreasonable statement. So based on these two things, we are going to accept or reject the hypothesis. So let's move on to the next slide. Okay, now let's start the hypothesis testing steps. Step 1 is about stating null hypothesis and alternate hypothesis, H0 and H1. H1 is exactly opposite to the H0. Step 2, select a level of significance. Level of significance basically determine the level of risk, which is denoted by the alpha. And this risk level can be 1%, 5%, and 10%. It's basically the risk of rejecting the true null hypothesis. Step 3, identify the test statistics. So we need to identify which test is going to be used because we have two options, t-test and z-test. So z-test is used when the population standard deviation is known, and t-test is used when there is a sample standard deviation is given. Step 4, formulate the DCN. So we will formulate the DCN and find the critical value. And by using this critical value, we will separate the rejection or acceptance region. Step 5, we will compare these two values. And at the end, we will conclude that to reject the H0 or accept the H0. So let's move on to the next slide. So these are the important things to remember about H0 and H1. This is the notation for a null hypothesis and alternate hypothesis. Null hypothesis is denoted by H0 and alternate hypothesis is denoted by H1. H0 and H1 are mutually exclusive and collectively exhaustive. So these two concepts are from the chapter 5, which is about the probability theory. Mutually exclusive events are those if one event occurs, the other cannot occur. And collectively exhaustive events are one event must occur. H0 and H1 are following the same scenario as the scenario of event A and A complement. These two events are exactly opposite to each other. H0 is always presumed to be true, so we always suppose that H0 will be true. H1 has the burden of proof. So the burden of proof is actually encompasses the two separate ideas. Then if we conclude H0 and H1, if H0, if we say that we do not reject H0, this does not necessarily mean that null hypothesis is true. So sometimes we don't have the complete information. So at that point, we do not reject the H0. But if we reject the H0, then it means that we will going to accept H1. Equality is always a part of H0. So these equality signs will always be in H0, and inequality signs will be stated into H1. So let's move on to the next slide. In this slide, we will see that the chance of error occurrence into decision making, decisions and errors in hypothesis testing. So let's start with the formulating a decision. If null hypothesis is true and we do not reject the null hypothesis, or you can say we accept the null hypothesis when it is true, so that decision will be a correct decision. So if we say H0 is true, but we reject the H0, so there will be a type 1 error. If H0 is false and we do not reject H0, so at that point, type 2 error will occur. If H0 is false and we reject H0, then decision will be correct. So this is the difference between error 1 and error 2. So let's see the definition. Type 1 error defines the probability of rejecting the null hypothesis when actually it is true. Rejecting the true information is basically the type 1 error. This is denoted by the Greek letter alpha. So this is the risk level we have discussed before in the steps of hypothesis testing. Alpha, also known as the level of significance or the significance level of a test. Type 2 error defined as the probability of failing to reject the null hypothesis when it is actually false. So we accept the false information which lies into the type 2 error, and this is denoted by the Greek letter beta. So type 1 error can be incorporated in the testing procedure. On the other hand, type 2 error does not. So we will see at the end of this chapter that how we can compute the information where is type 2 error occur. So let's move on to the next slide. So now we are going to see what are the left tail or right tail tests. The direction of test involving claim that use the word of has improved, is better than, and is like will depend upon the variable being measured. So there are some keywords used in the question description. So we need to find out that which kind of symbol will be used according to their places, because H naught is always use the equality sign. On the other hand, H1 uses the inequality signs. So these keywords will be used in different scenarios, and we will find out that which symbol is accurate for which keyword. So the left tail or right tail test. So if we say that smaller at least, no, smaller no more than, and is there a difference? These all these will be lied to on a left tail side. So it will be clear when we start doing the examples. So these are keywords which can be used in the question description and their respective symbols. Parts of distribution in hypothesis testing. So let's see what are the parts of a distribution testing, hypothesis testing. I hope you guys are familiar with this diagram because we have repetitively used in previous semester as well. This is the normal distribution, a bell-shaped curve. And at this point, you can see that there is a critical value which is separating these two regions. This is the rejection region and this is the acceptance region, or you can say that where we do not reject the H naught. So the probability of acceptance is 0.95, and this cut point is actually a critical value, and rejection region, so there is a probability of 0.05, and this is the scale of Z. Or you can say where we will plot the value of Z-score. So moving towards next slide. So there are two types of diagrams, one tail versus two tail test. So two tail test is actually the non-directional test where the critical value will be lie on both sides. On the other hand, one tail test or the left tail test, where the critical value will lies on the left side. On right tail test, the critical value will be lied on the right side of the normal distribution curve. So this is the hypothesis setups for testing a mean. If we have given the mean information into the statement, so how we will state that value, H naught mu is equal to that particular value, and then H1 mu is not equal to that value, or mean value is not this. So if we reject H naught, so this will be the formulation of DCN rule, alpha by 2. So it means that we have the two-tailed test. So the half is aligned on the right side and the other alpha will be lied on the left side. So this will be used for the Z and T test. And these are the general formulas for this scenario. So these symbols are used for the right and left tail. For hypothesis testing, we will follow these steps in each and every question. So if we have the percentage into the description, so we will use the proportion symbol for in place of mean. So in previous example, we have the setups for testing population for mean, but in this we will test a proportion. So H naught is a proportion to the this particular value, as H1 is not proportionate to the this value, then we will reject, and this is the DCN rule, and this is the formula for calculating the proportion. So let's move on and let's see how to apply these tests on practical example. Testing a population mean with a known population standard deviation. So at this point, we are already have the population standard deviation, so we will use Z-test. Jamestown Steel Company manufactures and assembles desk and other office equipment at several plants in western New York State. The weekly production of model A325 desk at the Feridona plant follows the normal distribution with the mean of 200 and standard deviation of 16. So they already mentioned the mean, the value we will use for mu, and this 16 is for sigma. Recently, because of market expansion, new production methods have been introduced and new employees hired. The vice president of manufacturing would like to investigate whether there has been a change in weekly production. So they are going to find out that if there is a change, or if this new hiring make any effect on the production quality. A production of model A325 desk, a sample from last year weekly production yielded a mean number of desks produced of 203.5. So this is the sample mean information, which means it's X bar. Test using 0.01 level of significance. So alpha is going to be 1%, or you can write as 0.01. So this is the information given to the example. So let's see how to compute this information. Testing for population mean with known population standard deviation. So let's see how to state the null hypothesis and alternate hypothesis. Step 1 is showing that H naught mu is equal to 200. Mean value was given, so mean is equal to 200. H1 is exactly opposite to this, that mean will not be equal to 200. So which keyword has been symbolized here? Keyword in the problem was given has changed, so that we use the equal sign here. So there is a change or there is not a change. Step 2, select a level of significance. So the level of significance also stated in the problem, and that is alpha 1%. Step 3, select the test statistics. So what test statistics we are going to use? So we will use Z distribution. Since sigma is known, so population standard deviation is known, so we will use the Z distribution. Now step 4 is formulate the decision rule. reject H naught if calculated value is greater than critical value. So alpha is divided by 2. If I draw a bell-shaped curve here, if you remember, under the curve area is equal to 1. 0.5 is lied on right side and 0.5 is lie on left side. So we have the alpha, or you can say the level of risk. So if we divide alpha on both sides, so the value will be lied on each side for the risk level is 0.005. So since it's a two-tailed test, half of alpha or 0.005 is placed on each sides. So based on half under the curve, we will find out that after subtracting the 0.005, what will we get? So the total area is 0.5 and subtract the 0.005. So we will get the value of 0.4950. So we need to find out the nearest value in the table of z-test, which is the appendix B1. So the nearest value is 0.4951 and corresponding columns has given the value of 2.58. It means 2.5 will be in the row and column of 0.08. So this value is lied here in the table. So we will get the critical value, which is 2.58. So then we will calculate the z value by using this formula. Here, this is the x bar, and we will put the value of sample mean here, and then mu is 200, and 16 is standard deviation, and n is 50. So why n is 50? Because we are computing the last year information. So on yearly basis, we have 52 weeks in 1 year, and there were 2-week vacations. So we will minus the 2 weeks from 52. So we will get the 50 weeks of production, mean production. So then this is the n. We put the value and we get the computed z value, which is 1.55. So this 1.55 says lied into the do not reject H naught region, or you can say where we accept the H naught region. So these two sides we will plot the critical value 2.58 and 2.58. And computed value is 1.55. So what is the DCN? Because 1.55 does not fall in the rejection region, H naught is not rejected. So we are accepting the null hypothesis. We conclude that the population mean is not different from 200.